Hello and welcome to another episode of whatever this thing is called. I was going to do a demonstration of one of my retro gaming boxes that I built over 15 years ago, but unfortunately, as I set up my demo, I couldn't get it running again, and I suspect that some of the internal components might have gone bad. Last time I booted was about a year ago, and even then it was quite shaky. Back in the late 90s, as far as I recall, there weren't really that many small computers around. Most consumers used either 15 to 19-inch size towers or desktop cases of roughly similar dimensions. And I was always upset about the large amount of dead empty space inside of those computer enclosures. I wanted to make them as small as possible. One of my goals was to have a computer that I could plug into my car and have with me on the road as a laptop substitute, because I didn't even have a laptop at the time. And this machine, it got inherited from a friend. I was helping him build his first computer around 1998, and then eventually when he was ready to upgrade, he just gifted me the motherboard, and it became the foundation for this device. Yeah, well, enough talk. Let's just disassemble it and see what's on the inside and what makes it special. Obviously, let's unplug everything first just to be safe. By the way, this is the button that would turn the computer on normally. And right now it's not doing anything. I mean, it can be even as simple as a damaged button. Maybe it got pressed on the inside. I don't know yet. But there is some spark I can hear when I connect this power plug. That electrical connection is happening. So it's just that the fact that the motherboard is not turning on, which could be for a number of reasons. Oh, anyway, this is what it takes to run this machine. The power connector straight from the wall, VGA cable. This motherboard contains an onboard graphics card. Unfortunately, I don't remember what kind, but the memory, as far as I recall, is shared with the main processor. So it's the same memory bank, slow SD memory, that is being utilized for both the graphics and the CPU. Alright, so the first order of business are the two main fans. That's what circulates air through the entire computer. There's nothing else. There are no assistance fans, and these are the ones that cool down the processor, the power supply, and everything else. Originally I thought about putting more fans in here, but I only had two fans, so that's why I have two, and I never managed to add more of them. By the way, this back panel, even though the color roughly matches the rest of the plastic enclosure, it is not from this box. This is the second generation cover. The first one was made out of plywood. I may have a photograph for it. And this one was carved from an old fax machine that I found in the trash, which roughly matched the color. So I took it home and cut off the paper tray section and made this cover that made the computer look like a complete unit. And if we were to have a peek on the inside, you can see that it's very tight. I'm going to show it to my primary camera as well. It's just, everything is crammed in there. How do we extract things? Well, the first thing to remember is to unplug any of the connections that do not separate automatically. For instance, this power cable that runs the two fans. That's one of the modules. Second cable is the one that transmits power to the power supply. And this may be the thing that maybe I didn't have it fully connected. That is a possibility. And the third wire is the one that controls front panel LEDs and the power switch. Another possibility is that maybe the wire got twisted or broken. Maybe it's just that the power button is not getting the signal all the way to the motherboard. We'll see. We'll find out. I may or may not be able to fix this today, but at least let's get it started. Let's get this project running, and if I have to come back to it in another episode, then I will. Alright, and the front panel that used to contain a CD-ROM drive tray, the dimensions fit the black panel of the motherboard almost ideally. Right now I'm going to push it out, not fully, just partially, and now I'm going to hopefully pull this out. Alright, so here's the panel, as you can see, and I only had to cut out one side because it was just getting pushed into the plastic. I could have carved the plastic on the inside, but I chose not to do that and instead chopped off one section of the panel, and it worked out nicely. By the way, this little hole that you see here, I had to cut it out additionally. This is for a switch that I added to the motherboard that's not part of the standard set, but again, another thing that I have to show you in a second. Alright, now I have to look at this side one more time to make sure that things are lining up, and keep pushing. Have to keep pushing from the back or the front. And with this computer, it's hard to tell which is the front and which is the back. Alright, and we're in. Almost done. I have to keep checking these two wires. Sometimes they get caught between the capacitors and the edges of this enclosure. So I have to just watch all the cables to ensure that nothing gets damaged. Alright, and we're almost done. Yes, we have extraction. Alright, and this is it. The biggest modification had to be done to the power supply. This is the power supply board. This is the main processor and the standard size hard drive that I'm really thinking about replacing with an SSD or a compact flash adapter. We'll see how this goes. The hard drive is located slightly above the PCI slots, and I used some of the slot cover brackets. I made them into L shapes and cut off extra bits, and I made two attachments on the left and right, and they're being held by the screws that would typically hold the motherboard to the case. But in this case I'm using them differently because the motherboard, it sits inside this plastic. It's not being physically attached by anything. It is simply squeezed between all the four corners of the plastic enclosure. Alright, and this is the back side. This is how the power supply fits in. Very nice. What's even nicer is what's on the other side of this power supply. Let me demonstrate this. I hope I can detach it without breaking anything. I hope I can remember how I put it together exactly. Alright. Here it is. Here's the main beauty of this case. This is the internal section of a standard typical AT power supply. I used a saw and I simply cut it into, and all I had to do was cut off the high voltage side from the low voltage and then put them on the side next to each other. And then I rewired this AT power connector and put it on another metal L-shaped bracket, which I screwed into one of the capacitor terminals, the capacitors that I have relocated to the right side. And then everything just somehow magically ended up fitting together. And I put my own additional little heatsink on this side for two of the MOSFETs. I think they were producing too much heat, and I made some improvised heatsinks on the other side as well, out of spare metal that I had laying around. Yeah, so even though this doesn't look very pretty, it just happens to function. So I got these power transformers being linked with these IDE cables to the place where their outputs used to connect on the board. So all I'm doing is just transposing this section onto that section, and no modification other than that. There are a few additional wires. I noted which other traces were had to be removed when I did the split. So yeah, that's pretty much it. And this power connector originally had more wires and wires were longer, but since I knew that I was only going to power one ID drive, I only kept some of the wires. I was mainly concerned about providing power to the motherboard, so I left this plug and another 5 and 12 volt connection for the hard drive. And the hard drive, this one rests above the PCI slots. There's an air gap, and that is done for ventilation purposes. Originally, when I was making it, I did something stupid. I used a piece of plywood for insulation, so between the hard drive and the motherboard, I had a rectangular piece of wood just covering the bottom because I was worried about wires getting in the way or maybe some loose screws damaging things. Well, anyway, I did that, and the computer ran for a while. It was absolutely fine until one day I saw magic smoke coming out of the system, and it turned out that by blocking ventilation of the bottom section, I ended up overheating the hard drive, and the lower circuit board at one point it just evaporated. So I fried one of the hard drives, and this is the second one that I'm using. Likewise with this board, the first one was quite similar, but it was just messier. Lots of wires and glue around. Oh yeah, and there was another issue with the power supply board, which happened in this section, and that was the primary reason why I ended up building the second prototype, was because this power transformer, there was this one weird thing happening. It was that when I built the computer first, I assembled it like this, when it was out in the open, everything ran fine. I would put everything back together, put it inside the plastic case, and then the system wouldn't start at all. It wouldn't boot. And then I would disassemble it again, test it again, everything's fine, put it back together, put it inside the case, and then it wouldn't run again. And as it turned out, as I discovered later, it had to do with this main power transformer. And the reason was that it was getting way too close to this hard drive. So when assembled like this, it was just getting a little bit too close, and because of that, the magnetic fields inside the coil, they were getting absorbed by this metal, and the transformer wasn't maintaining its electricity. It was maintaining its current. So yeah, the motherboard just wouldn't boot up whenever the transformer was too close and squeezed inside the case, and when it was up against the hard drive, then all the issues started happening. Right now, I suspect that I may have to replace these capacitors. That is the most likely scenario, is that they're probably not holding the charge, which prevents the power supply from reaching its full potential. I'll have to test these leads and to see what kind of current it is outputting. I will also test the motherboard with an external power supply. And I'll do multiple testing steps to see what's wrong and what can be fixed to get it running again. But right now, let me just assemble it outside the case and see if it'll power on. There's a 50% chance that it will. I just heard something beep. So I think, oh yeah, the system is trying to boot up. That's promising. Let's get the keyboard and mouse going. Let's find out what is going on with this system. Maybe it is operational. Maybe the bad connection was all there was. PS2. Am I doing it correctly? I'm doing it upside down. Alright. Alright, the system will probably complain about bad BIOS battery or something along those lines. Alright. Electrically, there is nothing weird going on. This side is, by the feel of it, is relatively cool. Alright. Let's press a few buttons and see what happens. What it's saying, system configuration has changed. Yes, I guess the battery just lost its charge. Oh yeah, there's this one interesting plug that I mentioned earlier. And that thing, what it does is it interrupts one of the USB ports on the front. And the reason I did that is to route some of the USB connectors to this board that I soldered to the PS2 connector. And this board is a wireless modem. It's a USB stick that used to go into the front USB, and I just decided that it would be nice to have an internal network support. Again, even back in those days, wireless networking wasn't all that common. It wasn't standard. So having a feature like that made the box really unique. And nowadays, it's probably even too old to connect to modern networks. It probably doesn't even support the WPA or WPA2 encryption types. It's probably one of the first generation Wi-Fi USB dongles. Well, anyway, so what that switch does is that it either connects data lines to this USB adapter, or it lets the USB port have access to those data lines. And while I was talking without doing anything special, I just noticed that the box went into sleep mode and started clicking. So now there is definitely a problem. Something is unstable. So after the machine stays on for a while, it just becomes dormant. How do I do this? How about this? Good enough for testing. Alright, so the green light on the other motherboard just came on. That is a good sign. And I still have to use the front button to get it running. Beeps differently now. I wonder what that means. Well, and here's the system in all of its glory, finally booting up. I ended up going through about 6 different memory sticks, which raises suspicion. The system was behaving a few times that it managed to partially boot. It was scrambling ASCII characters on screen, which resembles a memory error. Yet, I find it highly suspicious that 2 memory sticks would go bad at the same time. Additionally, I went, like I said, through a number of different ones, and they all acted as if they were bad. I suspect that it is very unlikely that all of my memory sticks were bad, but anyway, eventually I settled on the last 2 that I could find, which were PC100, not PC133, 64 megs each. So right now I have the system booted up with 128 megs of RAM, which is enough to run Windows XP at the basic level. We'll see if we can get that far. Another thing that I'm thinking is that yes, it is possible that the motherboard is having trouble sustaining 133 megahertz, but it is also possible that the CPU itself is not able to run at its full speed. Maybe this processor is bad, and I have another one that I can test out, an 800 megahertz Pentium 3. I may go to it next, but for now let's just watch this and see what happens. Alright, we can skip disk scanning. Oh yes, and obviously there is no sound because there are no speakers connected. There is a small PC speaker that is wired right onto the board, but for external sound, regular 3.5mm output jack is needed. Yeah, so the system is stable and running. I had it operating for about an hour now. with the two best memory sticks that I could find, which are both PC133, surprisingly, and 128 megabytes for a total of 256, minus 64, which is reserved for the graphics card, which is a lot more than I was expecting. Another pleasant surprise is that the wireless card is able to connect to my modern day router, detects encryption and everything, and I'm even able to browse the internet with it with very limited success. I get notifications such as with Firefox that certain CPU extensions are missing because it's expecting Pentium 4 at the very least. So some of those MMX, SSE, and those types of additional CPU codes that were introduced in later generation Pentiums, they're absent from this processor. So even though it can access the internet, it's not really meant for it. Before putting this computer back together, if it proves to be stable enough, I still don't know why it wasn't running the last two times. Who knows, maybe might have been a bad RAM connection, who knows. I'll do things with it to ensure that it is stable, and if it is, then I plan on swapping the hard drive with compact flash storage, because I do have a spare set somewhere, because then with a smaller hard drive it will be more quiet, you'll consume less electricity, and there will be more space on the inside for the ventilation, because most heat is being produced not even by the processor but by the power supply, and the fans that I'm using, they're quite underpowered. They're not sufficient for giving optimal cooling to this system, and additionally the case is made of plastic, which is a big negative. Plastic is a poor conductor of heat, just like my last hard drive that fried because I used plywood to insulate it. This motherboard goes through significant thermal stress when it's running because of, once again, because the case is made of plastic. Nowadays I know there are some companies that deliberately make vintage looking cases, sometimes even inside wooden enclosures, and they do it on purpose, but then they have to compensate. They have to install extra ventilation, they have to put more fans that would have been needed otherwise if the case was metallic, and sometimes on the inside they even put aluminum or tin plates to distribute the heat along the surface, because the wood would not do that. It would isolate the heat around its source. So they have to do some sort of tricks to alleviate the overheating. Well, so far I've been talking for a few minutes, and looking behind me, the screensaver is still running, so the system is surprisingly stable. I guess the next thing to try out would be to put the original power supply back in and see if the issue was really memory related. Alright, now the moment of truth. The motherboard is reunited with its original power supply. We'll see if it turns on. It's making noise. That is good. No strange beeps. Display comes on right away. So far so good, but I'm noticing that unlike with the full-size power supply, the CPU fan is changing its RPM slightly, which makes me believe that the 12-volt rail of the power supply may be running unstable. Later on I will connect an electrical tester or maybe even an oscilloscope to observe exactly what is going on, if it's able to handle the load. Even if the power supply is getting partially weaker because of its age, replacing the hard drive with a compact memory module should make another 5 to 15 watts of electricity available for the motherboard, so it should prolong its lifespan if power supply is of any concern. But for now, I'm almost ready to wrap this little experiment. I got the box running. I'm not going to put it inside of its enclosure just yet. I'll leave that for another episode, as well as the process of me cloning the hard drive and trying to get the operating system running off a compact flash replacement. Hopefully it's going to work out, but we'll find out in another episode. See you then.